Second part of homework 10, I'm going to demonstrate the counter for the traffic light. And I guess just a reminder of what this one does is that the count is counting the number of cars that trigger the sensors, and also is maintaining so that east west remains green for a certain amount of time once it's been triggered. For the code for our counter, I have my inputs to be clock and reset. My other input is car, which is the signal from the FSM, which enables the counter to count the number of cars that trigger the sensors. And WT is another input. WT stands for watch timer, which also comes from the finite state machine, and it keeps track of the time um, for that east west remains green. And my outputs is timer, which is 3 bits, and which outputs the time, and this is sent to the finite state machine as an input. And I also have a count, which is an output that is 3 bits, and it outputs the number of cars that trigger the sensor, which also will be sent to the finite state machine. Here in my architecture block, I have created 2 signals. I have a EW temp, which is east-west, which stands for east-west temp, and it's 3 bits. And so with this and reason for it is because it allows for the value to change easier than just having it just using the car signal, and as well as a signal for green timer, which basically keeps track of the time for when east-west remains green, and it's also 3 bits. In this process block, we have a clock and reset for as a sensitivity list, because this is when it'll check. I guess I should also have one for WT and car, because those are the values that will be changing as well. And so here, when reset is equal to 1, it will reset the system for the counter. So both the counter for EW temp and green timer is going to be 0. And if when reset is 0, in our else if condition here, it's going to follow the rising edge of the clock. And so once it follows that, this is when our conditions for WT and car will come into play. So in this if statement here is it's when WT is equal to 0 and car is equal to 0. This basically allows the timer to reset. So here we have green timer is equal to 0. So the reason why we want this timer to reset is because we don't want the last value to be saved when the timer is being disabled from the finite state machine. So each time it turns green, we want it to start from 0 to count up to 3, which is the max amount of time that we're allowing the light to remain green for east-west. This else if statement here is we have cars equal to 1 and WT is equal to 0. So WT will remain, it will basically remain here for green timer 000. And this allows the counter for east-west temp to increment, because car is 1. So this, which detects the sensor which comes in from the finite state machine. And the next statement is WT is equal to 1 and car is equal to 0. So this disables the counter here. So this basically voids this else if statement. So that way it's not, this statement is not overriding this statement, because it's, if it looks for cars equal to 1 and we don't have this and, it'll continue to increment this statement here. So here we have to ensure that the control from the finite state machine is sent as WT is 1 and car is 0. So that the green timer can begin to increment. And this right here is for when, how long it dictates, it increments the time, amount of time that the green light for east-west remains green. And here we have our outputs. Green timer will feed into timer, and east-west temp is equal to count, which will then be sent to our top level once it's all connected together. But these are our outputs for the counter. For our waveform, we have, I force the reset to be a 1 to reset the system, so that the timer and the counter, the timer and the count can be instantiated to 0. And I've then, for the next rising clock edge, I force the reset to be 0 and for car to be 1. So basically, now that the counter for the car, for the number for when the car sensor triggers the sensor, it'll allow the count to increment. And I also have kept WT to be 0. And as you can see here, it won't really increment until the next rising clock edge, and then as you can see that while car is still 1, count is now 1. And then as we go to the next rising clock edge, it's going to be count is now 2. And the next one, count is now 3. So now when we, in the next clock edge, at the next clock cycle, we I set car to be equal to 0, and I then set the value for WT to be 1. And it hasn't quite registered yet until the next clock cycle. But so right now, it's the count is 3 and the timer is 1. And so in the next cycle, as we can see here, when WT is 0, the timer now begins incrementing, and the timer is now 1, and the count stays at 3 because car is 0. So it'll pause the counter. And the next clock cycle, the timer will now be 2, the count is still 3, and here the timer is now 3 and the count is still 0. I'm sorry, it's still 4. I'm sorry, if I've read it as 3 for the last 3 cycle, I've meant to say that it's still 4. And then here I set the WT to be 0 now, and because it's at this rising clock edge here, so it's still a 1 at this point here. So the next clock cycle, the timer will not will reset itself at the next clock cycle, but the counter will still remain the same. So at this point, while timer at this particular clock cycle here, while the timer is now 0, the timer is 4. Well, when WT is 0 now, timer is still 4 in this case. And then till the next clock cycle, it's when, as long as we still keep that WT is 0, timer has now resetted itself to 0, 0, 0, and count is still 4. And that is all.